Thank you very much. My name is Charles Tabner. I'm the Chief Operating Officer at Magma. Everyone knows about M-pipe for the more demanding applications like the pre-salt risers. But what I'd like to talk to you about today is that same standardized project and its ability to impact the costs of marginal fields. When we founded Magma 10 years ago, we had one simple objective. That was to tackle the 5 challenges that we saw in steel and non-bonded flexible pipes. Those were corrosion, fatigue, high pressure, high temperature, and the speed and ease of installation. So if I talk through each of those existing products, and then we can move on to M-pipe. Steel is a fabulous product, and steel pipe have been with us for many, many years. But steel by its nature is heavy and has a number of challenges, as we talked about on the previous page. And what that leads to is complexity in engineering. So over the last 50 years, we've developed enormously sophisticated engineering solutions to deal with these challenges, and we should be proud of that work we've done. But as costs become more challenging, the impact of that complexity is cost, and we need to find a way of simplifying. Similarly, the non-bonded flexible offers a number of opportunities to improve over the steel pipeline, but it still retains many of the same materials and in fact has become a ferociously complicated product in order to do all the things we need it to do. And if we look on the right-hand side at this report from PSA Norway, we can see the impact of that complexity. As the years have gone on, we've seen more failures of this type of product that's directly related to that complexity and sophistication. So what we did at Magma was go back to a simpler all thermoplastic product. And what I want to do is give you a couple of examples of where that simple standardized product has been used in marginal fields. The first of those is a 6-inch, 30-meter jumper, replacing a steel hydrocarbon jumper in the North Sea. And on the right-hand side, you can see that product being lifted in by the crane. So much, much simpler installation. There's no lifting frame for it. There's no need for metrology. And crucially, a much shorter lead time from order to installation. Similarly, on the right-hand side here, you see a smaller diameter, high-pressure lines for sour service, and we've got 2 40-meter jumpers here that are designed to be installed much, much more rapidly, much more simply, and at a low cost. And crucially, this particular product was installed just 8 weeks after Magma received the order. A lot of people ask us how, when we use such premium input materials, we're able to reduce the cost of the overall product. So first of all, let's just talk about the pipe itself. I think this is one of the things, the oldest things in engineering. By putting in high quality materials and processing them with high quality process, what we're able to do is use less material to achieve the same thing. So the illustration on the right-hand side shows this very, very clearly. At the top, you see an M-pipe. In the middle, you see another thermoplastic pipe with the same performance characteristics. And at the bottom, you see the equivalent non-bonded flexible. And it's easy to see here, it's just less product with the M-pipe. That means less manufacturing. And quite often, that translates into just a simple saving on meter per meter of product. When we step to the fully installed cost, some of those differences become more stark. In this comparison that Total did for a West African jumper system, you see the cost of the steel jumper on the left-hand side, the non-bonded flexible in the middle, and the M-pipe on the right-hand side. As you'd expect, the steel jumper on the left-hand side has a lower cost of materials, but even once it's fabricated, you can see that the cost of that jumper is greater than M-pipe. And as you'd expect, the fully installed cost is much, much greater with the complexity of lifting frames and larger vessels. Also, as you'd expect, the non-bonded flexible is more expensive, and that, as you would expect, is driven by the end fittings. Installation costs very, very similar, although even there you see a slight increase because of the additional weight. And then, as we would expect on the right-hand side, you see the end pipe product that is lower cost in all respects compared to the other two. The final advantage of the end pipe solution in this type of application is just the sheer simplicity of manufacture. So we only have two materials, carbon fiber and PEEK, and the manufacturing process has a single process that is the same, whatever the diameter, whatever the length of pipe. And what that translates into for you is speed of manufacture and ease of manufacture. So as we illustrated on those two previous slides, you can see that the lead time for this type of product is much, much lower than other options. That's all I really wanted to say, but the key point of this message is it's one standardized product, and that one standardized product is simple, and that can translate in marginal fields to a lower cost and a more rapid installation. Thank you very much.